All right, part two of this thing. I had made it and decided that it just didn't have what it needed to have on it, so I added a little bit to it. I'm sure you're happy to hear that. Because it didn't have what I was talking about on Monday and Tuesday. You said a brain fart, I forgot to put it on there. So here we have a recursive rule. You're supposed to write the first four terms. And remember, this is the previous term. And the big thing is here is this is the common difference. It's what we add or subtract, okay? So the first five numbers, it should say terms. I need to fix that. The first term is literally -2, because that's what goes here. The second term is to take -2 and add 3. You take the previous term, you add 3, and you get 1. And you just keep that pattern. The next term, we add 3 to 1. I'm going to write this out for those of you who might be a little dense. You get 4. The fourth term, 4 plus 3, 7. And the fifth term, 7 plus 3, 10. It's not a hard problem. Last year, like 1 and 2 kids couldn't answer it. Those poor kids. Convert from recursive to explicit. So you will have to have this down. A sub n is the first term plus d times n minus 1. And we're going to grab all that information from the rule. -2 plus 3 parentheses n minus 1. Then you're going to invoke the distributive property. We're going to have 3n minus 3. And we're going to combine -3 and -2, and we're going to get -5. And that is the explicit rule. Hopefully you guys understand what explicitness means now. Express. Ooh, we got sigma notation. The sum of the first through fourth terms of 2n minus 3 is a series. So what we have to do is we have to figure out what these terms are. By the way, what this is asking, it's saying find a sub 1, find a sub 2, find a sub 3, find a sub 4, and just express it. It's not saying give me a result. It's not actually saying, it's just saying express what it would look like. So if I plug a 1 in, I'd have -1. If I plug a 2 in, I'd have 1. If I plug a 3 in, I'd have 3. And if I plug a 4 in, I'd have 5. And it's just saying express what it's saying. Show that you understand what it means you do. The next one, find. This means actually find the sum of terms 1 through 9. That's what it means. Find the sum of terms 1 through 9. Now, you could write this out. It's, if you want to, it's fine. 3 times 1 is 3, add 4, you get 7. Plus, put in a 2, you'll get 10, I think, won't you? 6 plus 4. Plug in a 3, you ought to get 13. You should get 16. You should get 19, 22, 25, 28, 1, 2, 3, 4, 5, 6, 7, 8. Is that 8 terms? And then 31. And then you can add stuff together, right? You can do that. Which I'm kind of tired. What do we have here? We have 17, 30, 46, 56, 65, 87, 112, 140. I came up with 171. Is that right? I don't know. Or you can use that little formula that Gauss gave us. Let's see, it's Carl Frederick Gauss, G-U-A-S-S. And his formula says the sum of n things is n over 2 times the first term plus the last term. So I would have had to find that guy and that guy. I would have had gone off the side and said, okay, a sub 1 is 3 times 1 plus 4, which is 7. And the ninth term is 3 times 9 plus 4, which is 31. And 1 through 9 things is 9 things. The sum of 9 things is 9 over 2. In the parentheses, the 731, 7 plus 31. So the sum of 9 things is 9 over 2. If we put these numbers together, we get 38. By the way, it's easier to do the math like this because half of 38 is what, 19? I mean, 90 and 81, 171. I trust that. I trust myself more with multiplication than I do with addition of long strings of numbers. But I got 171 both ways. I don't really care how you do it, to be honest with you. So pick your poison, all right? That's the big deal. Pick your poison. Which one are you going to do? Pick it. And the last one. How many terms of the arithmetic sequence 1, 3, 5, 7 will give a sum of 961? I have no desire to write this out. I'm not going to. I'm not doing it. I'm going to use Gauss's formula. And like I said, an 8th grader came up with this. And not an 8th grader, an 8-year-old came up with this. He was 8. He was 8 years old. Surely you who are twice his age can do it. The sum of n things is n over 2, first term plus last term. And the thing is, I don't know what n is, but I do know the sum. This can go right here. This can go there. What's going to go here? What's the last thing? The last thing ain't 7. Write your rule. The nth term is the first term 1 plus n minus 1 times the difference of 2. So a sub n is 1 plus 2n minus 2. A sub n is 2n minus 1. So 961 equals n over 2. First term is 1, and then plus 2n minus 1. Okay, look how well this works. The 1's cancel. 961 equals n over 2 times 2n. The 2's cancel. 961 equals n times n. 961 equals n squared. Why do I feel like something's wrong with that? Like, it better be 19. Apparently my squares table's off in my head. So let's check my math here. But it better be 19. Square root of 961 had best be 19. 31. Boy, I'm off. Where did I get 31? I'm thinking cubes. That's what's going on. 31 squared. Ugh. Been a long day. 31 terms. There you go. All right. That's that. And I'll probably let you use a calculator. Usually, with the exception of basics, I let kids use calculator on assessments just so I can have better numbers. 31 terms. And that's that. Later.